Yo, what's up, guys? So we've been working on linear expressions, which is just patterns that go up consistently. We have that common difference rate of change, and we're going to look at how to do that and how to write these expressions so we don't have to make tables that are like 50 entries long, so we can find any value. So let's get started. So at first we have this problem here. We have a pattern. It's a geometric pattern. It's dealing with squares. Doesn't always have to be though. It could just be a pattern that is related to a table, a data set, whatever. These all work the same as long as they have a common difference. So what I'm gonna do first is I'm just gonna look at this problem. I see three figures, I see a bunch of squares. I've got 5 tasks that I gotta do. Get that out the way. Create a table, 1 through 5 with the figures, how many squares, write a number of in a sequence. I gotta know what a sequence is. Does it have a common difference? I gotta find it. I gotta know how many squares would be in the 10th figure, write an expression, and then use that expression to find the number of squares in the 20th figure because I don't want to make a table that's 20. I could change that to 50 or whatever. So let's check this out. It's blurry, but we're gonna make a table first. So the first thing to do when you make a table is figure out what's your independent variable, what's your dependent variable. And in this one, my x is going to be figure number, and then my y is going to be the number of squares. I know this because the number of squares is going to go up or down based on my figure number. It's not the greatest, I know, but let's work with it. So figure number 1, if you go back, let's take a look real quick. Looks like we got 4 squares. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Number 2, 1, 2, 3, 4, 5, 6, 7, 8, and number 3. So it looks like 4, 6, 8 is the pattern. So 4 squares.
Jerry, go ahead. Can you come to the main office, please?
6 squares. Sorry, guys. 8 squares. Keep it going. What's the 4th one going to be? It's going to be 10. What's the 5th one going to be? It's going to be 12. Now, I got to know what the common difference is. And the common difference is really same thing as saying, sorry, I'm trying to figure out how to change my pen color. Is the same thing as a pattern. What's the pattern? What's the common difference? So from 4 to 6, didn't change color, let me try again. From 4 to 6, we went up +2. From 6 to 8, I got it now. We went up +2. From 8 to 10, we went up 2. So if I know what a common difference is, which is the difference between consecutive terms, it's going to be 2. So the other part of this was write our number of small squares as a sequence. A sequence is just a list of numbers. So my first term will be 4. My second term will be 6. My third term will be 8, 10, and 12. And I know this pattern is going to continue, so I put the 3 little dots, and that's really hard for you to see. My bad. But I know the common difference is +2. Any questions, make sure you ask, but this is a table. We could keep it going. And if we did keep it going, we would be able to find the 10th figure. Justify using the sequence of the table. I don't want to make a whole nother table. So I know the 5th figure had 10 squares. So the 6th figure would have 12, 7th would have 14, 8th would have 16, 9th would have 18, and the last one would be 20. So I know right now, just by using the sequence or the table, the 10th figure would have 20. It took a little bit of time for that. I don't really want to do that more than I have to. So let's say I'm tasked with finding the 20th figure. I don't want to have to keep doing this. So I'm going to find a way to write an expression where my variable n is just a placeholder. It could be 1, it could be 10, 20, 50, the number of any figure in the pattern. So I gave you guys a little bit of a formula, so we'll talk about that. So to write this expression, there's more than one way. I just have my preferred way, so that's what I'm going to roll with. And it requires the first term in the pattern. And the first term is always going to be a value, so it's the y value. So what we're starting with, you start with it. And then we add on every time. What are we adding on? The common difference or your rate. So the common difference in this case is something that's going to go here. And then to figure out how many times you can add on to or add on the common difference, you have to multiply by something. And we multiply by n, which in this case, n is any figure number in the pattern, whatever we're looking for. And then we're going to subtract the first term number and that's an x value. So if the first term in your table has an x value of 1, that's where that 1 goes. So let's do this. So my first term in this table, if I go back, was 4. That's my first term. So my first term is 4. And then I add on. What is my common difference? My pattern is +2, so I'm going to add 2. Then I'm going to get my parentheses in place. Now n, I don't know what n is yet. I'm not doing 25, I'm doing 24. I'm using n, so n goes here because n is any figure number that I'm looking for. Then I got to subtract based on the first term number, and that's going to match up with your y value. So my first term number is 1 because 4 is the first term in the table. So even if I didn't know this was a 1, I'd know it would be a 1. Math data usually starts at 1 or 0. There's ways to do it correctly with both. As long as you justify what you're doing, we're good. So I'm going to subtract 1. That's my expression. I have my first term, which is 4. Let's change the color. I have my common difference, which is 2. My placeholder for any figure number that I'm going to look for, and then 1. So we should be able to do 25 right now. Now, what I want you to realize is that the connection to the expression in the table. So before I look for 20, I'm going to look for 10. We already know that when n is 10, I'm going to get a 20. So when n equals 10, I'm expecting a 20. Let's use our expression to make sure that holds up. So I'm going to do 4 plus 2. Now, n is no longer a variable. I know what n is, and n is a 10. So in parentheses, I'm going to substitute using parentheses always. Put a 10 in, minus 1. At this point, my expression is ready to be simplified. I just have to do the math. So at first, I'm going to take care of what's in parentheses and get a 9. 4 plus 2. Keep that 9 inside parentheses. Now that's going to tell me that I'm going to get 18 plus 4. And I did something wrong. 22. So let's rewind just a little bit so I can make sure I'm doing this right. So if I go back to the table, oh, I know what I did. 5 was 12, not 10. So this is the 5th term. This is the 6th. This is the 7th. This is the 8th. This is the 9th. The 10th term is 20. My bad, guys. I wasn't paying attention, didn't check my work. That's a lesson right there. Everybody makes mistakes. So the 10th term is 22. So if n is 10, the y value that goes with it is 22. There's 10 figures, I'll have 22 squares. I can write that as an order pair because that's that data set. So let's find the 20th figure. I'm going to do it the same exact way. I'm going to use my same expression that I got. 4 plus 2 times n minus 1. But this time, what's n going to be? Right, it's going to be 10 or 20. So we get 4 plus 2 parentheses 20 minus 1. Now follow your order of operations rules, PEMDAS. Do what's inside of parentheses first. 20 combined with a negative 1 is 19. 4 plus 2 times 19 is going to be 38 plus 4. So your value when x or n, your figure number, is 20, you're going to have 42 squares. That's all there is to that one, guys. If you have any questions, let me know. Let's have a little fun. So I was trying to play Fortnite last night, but for some reason my PlayStation 4 updates so slow, and it took at least 3 hours for Fortnite to update. I had to sleep. I had to come to work today. You guys didn't, so you were probably up all night playing Fortnite. But anyways, bought the Battle Pass last season, so my Battle Pass is ready to go. Now, I bought the Battle Pass this morning, so I'm ready to go, but I didn't get a chance to play yet. But I noticed as soon as I bought it that I reached tier 6, and now I'm wondering if there's any math behind that. So I'm already at tier 6. I haven't played a game yet. It's day 1 of the season. So my question, how long will it take me to get to level 100 on my Battle Pass? I'm going to be honest, last season it didn't happen. I think I ended up at 70. I got real lazy, slacking. Didn't really want the Ragnarok skin. And I'm not going to get a Fortnite anymore. But I had level 100 the last couple seasons, so let's get back to that. So I want to know how long it's going to take to get to level 100. First, let's think about this in terms of how quickly do I expect to level up my Battle Pass? I don't know what's feasible. For you guys, I don't play that much, so I'm going to aim just for, three battle tiers a day. That's going to be my goal. Get 3 a day. So 3 tiers per day. I know it changes. So it's going to be on average because some days you'll get your challenges, some days you won't. But I'm going to aim for 3 tiers a day because I think that'll give me enough time. I don't know how long the season is, but about 10 weeks. How many days are in a week? 7, 10 times 7, it's about 70. That'll give me some time even if I don't play to get to it. So I'm going to aim for this. So how many days do I have to play if I get 3 tiers a day to get to level 100? I don't know. I could make a table, right? So I could set my table up. What would my X be? Well, if I want to get my tiers up, I got to play. So the tiers is independent. So that's my tiers. My X value is my X is the number of days I play, and Y is the battle pass tiers. That's my Y value. Now it's day 1, right? I technically didn't play, but I did log in, so I'm gonna count it. And on day 1, I got 6 tiers already. Got to come up. So if I play today, if I play tomorrow, and I get 3 tiers, what's gonna happen? Go to 9. And if I play again, we'll say Saturday. I'll probably play Saturday. I'll have 12. Do you want to keep going till you get to 100? I don't. It's gonna take a while. So let's do this using our expressions. Remember, I was talking about, there's always ways to do things in math. Just, do you want to use a butter knife or a chainsaw? I'm gonna teach you to use this chainsaw. So let's do this. We set up our formula. We need our first term. Our first term in this table is going to be a y value, and that y value will be 6. 6 is my y value. It's my first term in the table. Then I got to add my common difference. Finding common difference is finding like what's changing. And my battle tiers is changing, and it's changing every day a certain amount, and that is 3. My common difference has to be 3, and I can see that in my table. I'm adding 3 each time, and I'm going to assume that it'll be the average. Now, I don't know how many days I have to play, but I know that X is going to be my tiers, and that's the unknown. That's my variable. And again, I showed you guys how to simplify this, and I might do that this one because I don't want to deal with the parentheses anymore. But on the first day, I already got 6 tiers, so that's where that term number comes from. Let's simplify this expression, though. I'm tired of parentheses, as I just said. So I have to apply the distributive property, and I'll get 6 plus 3x minus 3. Then we got to do some CLT, some cucumber, lettuce, tomato sandwiches. Throw a little hummus on there. 6 minus 3 is 3, or 6 with a negative 3. So 3 plus 3x is my expression. Just a reminder, these are equivalent. Things in math that are equivalent, they have the same value. They do the same thing. If you don't believe me, test it out. Now, we're not at equations yet, so I'm not going to show you that just yet. But let's try to figure out how long this is going to take. I know some multiplication, right? I know some facts. I'm trying to get to 100, or as close to 100 as possible, to guesstimate how many days it's going to take. So change that color. If X is, let's see, 20 days would be 60, that's too low. 30 days would be 90, that's close. Let's try 32 days. I just got to play 32 days. I can do that. And if I don't, y'all need to get on me. I need to get my battle pass to level 100 this time. I really like that vampire girl, Dusk, I think it's called. I like that skin. So I'll use my simplified expression. You can use the other one if you want. 3 plus 3 times 32. X is 32. I know what it is. It's not a variable anymore. So 3 times 32, 3 times 3 is 9. That's really tens though, so that's 90. 3 times 2 is 6, so that's going to be 96. That'll give me 99. Hey, I'm almost there. So if I play 33 days, I got it. I'll be over. So 33 days, a little more than 32 days. This obviously would change depending on your battle tiers. So what I want you guys to do is calculate for me how many days it's going to take you to get your battle pass to level 100. I'm going to get 3 tiers a day. How many days do you have to play? Some of you guys get a lot more wins than me. Y'all got to carry me. So let me know what you get, how many days it's going to take, and show me the math. If you guys have any questions, you know where to find me. We're at Mr. Hands at 4-on-4. Catch me on Twitter. Let me know what you need. And as always, guys, take care. I'll see y'all later.